Good evening, Bhavagna.
Good evening, sir.
Good evening, Sumuk. Sumuk, good evening. So in last class we had which topic we had discussed?
Sir, good evening, sir.
Good evening.
Sir, one question doubted, sir.
Okay, so what's your doubt?
Sir, in chemical reaction and equation, sir, 1 minute.
Okay, please share your doubt.
Sir, it is balancing equation. Lad.
What doubt is there?
Sir, it is about balancing equation, sir. 1 minute, sir.
Okay, please share. Please share about the balancing of the equations. Today we'll be carrying on with the revision of acid, bases, and salts. That's your chapter 2. Right? We'll quickly revise the chapter today, and in next class we'll try to discuss the question answers from that chapter. Okay.
Sir, sent.
Okay. So you sent here in the chat section.
Yes, sir.
Okay. Lead acetate solution is treated with dilute HCl to form lead chloride and acetic acid solution. All right. So first of all, how many of you have any doubt regarding formation of formula or writing the chemical formula? Is there anyone who has doubt regarding the writing the chemical formula? Okay. So see, you have lead acetate solution treated with dilute HCl. So the formula for lead acetate is, first we write the given equation. You have lead acetate being treated with dilute HCl. Okay. And the products obtained are lead chloride. Okay. You have lead chloride and acetic acid.
Yes, sir.
Okay. So first of all, acetate ion. The acetate ion is this CH3COO minus. This is acetate ion. CH3COO minus is the acetate ion. When we say lead acetate, so lead has the valency of 2. So you get the formula as Pb, and here you have CH3COO twice. Lead has the ion valency of 2, so acetate has a valency of 1. You get the formula of lead acetate as PbCH3COO2. HCl will have the formula of, this is your HCl combining to give lead chloride. So lead chloride formula is PbCl2 plus acetic
Yes, sir.
acid, which is CH3. Okay. Acetic acid formula is CH3COOH. Okay. Got the formula of acetic acid?
Yes, sir.
Okay. Now lead acetate plus HCl will give lead chloride plus acetic acid. Now we need to balance it. So to balance this, you have two acetate ions CH3COO. You have here CH3COO. So there must be two acetate ion over here. You get right here two. So this acetate is balanced. And to balance the chlorine, you add here two. And now you will observe that everything is balanced.
Yes,
Okay.
sir.
Got it?
Yes, sir. And sir,
Either you. Hmm,
no, sir, that's it.
okay. Either you go by that metal method. First you balance the metal, then you balance the non-metal, you reach the same thing.
Okay, sir.
So today we are starting with acids, acid, bases and salts. That is your chapter 2. So there are different concepts of acids. Okay. Like different scientists, they studied acids in different ways. These are the some of the concepts here. For acids, you have like what substances can be called as acids. Okay. Commonly, we call acids to be the substances which are sour to taste. Okay, so acids are the substances that are sour to taste. But this is not a good definition because you can't taste every object. You can't taste every object and say that it is sour. All right. So acids, they are the substances which are sour to taste, and therefore we required here some better definition for the acids. So some of the acid definitions, these were, first of all, acid definition was given by Arrhenius. We have Arrhenius concept of acids. Okay. Then we have Bronsted and Lowry concept of acids. All right. And at the last we have Lewis acids. So these are the some concepts which help us in understanding the acids, bases, and salts. Okay. So if somewhere in paper like you are given according to the Arrhenius concept, according to the Bronsted and Lowry concept, so don't get confused. Okay. For your level, they are just the names. Okay. For you, what are acids? The substances which are proton pairs. Okay. The substances which give H plus ions in their aqueous solutions, they are acids. Alright. So the substances which give H plus ions in their aqueous solutions, they are acids. So we take any substance, we put them in their form their aqueous solutions, and we see if they can donate H plus ions. So remember, if we take any of these substances like HCl, you take HCl, you take H2SO4, you take HNO3, alright, you take here H2CO3, you take CH3COOH. So all these substances, they are the ones which give H plus ions in their solutions. So for HCl, if you add water, you'll get H plus ions over here. And for H2SO4, you add again water, you'll get H plus ions. Right? HNO3 will also give us H plus ions. H2CO3 will also give us H plus ions. So that is why they all are termed as acids. CH3COOH will also give the H plus ions. Now, depending on their origin, from where we are obtaining these acids, we classify these acids as We classify these acids either as organic acids or mineral acids. Right? So what are mineral acids?
Sir, they are partially no, ionized.
Which one?
Sir, mineral acids are those which are partially ionized. No, no. Weak acid. Sir, mineral acids are those, sir, that are prepared, sir. Prepared in a laboratory.
Mineral acids are the ones which are
Prepared in library, sir. Laboratory, sir.
okay. They are prepared in laboratory.
And organic ones, acids are found naturally, sir.
Okay. See, organic acids are the acids which are obtained from the living organism. They are the organic acids. Whereas mineral acids can be prepared in the laboratory. So almost a very good approach you made. Got it?
Yes, sir.
So organic and mineral acids. So these acids like HCl, H2SO4, HNO3, H2CO3, they are all mineral acids. Okay. This CH3COH and oxalic acid, citric acid, these acids, they are organic acids. So depending on the origin, we divide acids into two categories. We divide acids as either organic or mineral. We have mineral acids or we have organic acids. Alright. So organic acids are the acids which originate organically or from the organic substances. Mineral acids are the acids which can be prepared in the laboratory. Now we have some two other concepts like strong acids and weak acids. Okay. So what are strong acids and what are weak acids?
Sir, strong acids are completely ionized, that is in aqueous solution. They give out
Mhm.
H plus ions completely.
Mhm.
Whereas weak acids, they partially ionize, that is, they give out less concentration.
Okay. So strong acids, they completely ionize. Strong acids, they completely ionize or completely dissociate. Whereas weak acid do not completely ionize. So do not completely ionize or completely ionize. It means that okay. So if you have HCl, so it is like this. If you have HCl here, suppose you have 10 molecules of HCl. So or let's say you have 100 molecules of HCl. So HCl disintegrating to give you H plus ions and the chloride ions. This is how we have studied the ionization. Right? So it means that out of these 100 ions, if you have a total of 100 ions, maybe out of 99 or 98 ions are breaking up or splitting up to give you H plus. Okay. So this will be considered as a strong acid. And weak acid is the one uh, which does not ionize completely. For example, for the CH3COOH, if you consider its dissociation or ionization, so if you consider the dissociation or ionization for COOH, you get the acetate ion CH3COO minus plus the H plus ions. Okay. So when we study the dissociation for this, we have the acetate and the H plus. Now in this case, what would happen if you have suppose 100 molecules of CH3COH? So maybe 70 molecules or 80 molecules they are disintegrating to give H plus. So this will be considered as a weak acid now. Understood what is the difference between a strong acid and a weak acid? Okay. And also you can say that there is no strict line between the two. There is no strict line by which you can say that this one is a strong acid and this one is a weak acid. Like similar to your class. In your class, you can't say that this is a strong, and you can say obviously that this is a strong. This one child is an intelligent and this one is weak. You can say that, but you can't draw. You can't divide your class into two halves on the basis of who is strong and who is weak. Are you getting? So the same thing happens with the strong and weak acids also. We have strong acids, we have weak acids, but we can't eventually say or draw a strict line between them, separating the strong and weak acids. Okay, we'll come to one more concept, that is concentrated and dilute. We'll come to that. But before that, let's see formation of the ions, how the ions are formed over here. So you have CH3, let's say we take HCl or CH3COH, any of them. Suppose we take here HCl. So what we have studied, that HCl when forms or when dissolved in water, it breaks up to give H plus ions and chloride ions. So in the solution you will be having H plus ions and chloride ions. But this is certainly not true. This is not what happens. In this case, you have HCl disintegrating to give H plus and chloride ions, along with water also dissociating. So here water all dissociate to give H plus and hydroxide ions. Okay. So when dissociation occurs, when we observe the dissociation occurring here, when we dissolve any acid in water, so we have the formation of H plus ions from the acid and we have the formation of H plus ions from water. So both of them, they are forming the H plus ions. And in the solution also, we have, however we say H plus ions, but the H plus ions, they are highly unstable. The formation of the H plus ions, they are highly unstable. Got it?
Yes, sir.
So unstable means in the solution you will not be finding H plus ions as it is. The H plus ions, it will be combining with water molecules to form hydronium ions. H3O plus. This is a hydronium ion. Okay, so in solution, H plus ions exist as hydronium ions. However, we generally say that is H plus ions. Alright. Now, an important question. Suppose an acid is dissolved in water. So, does the solution contain hydroxide ion also? Yes. Aryan, does the solution contain hydroxide ion also?
No, sir.
No. So, see here we have written hydroxide ions. If you add up the reactions, you are getting hydroxide ions in the solution. You have a strong acid HCl and a strong acid HCl dissolved in water is giving you H plus and the chloride ions. Okay. So, for this case, you have H plus and chloride ions. Now, what can you say? Are there hydroxide ions in the solutions? You have OH ions which appear from water.
No, sir.
No, sir.
The answer is yes, there is. Even if it's an acid, even if it's the strongest acid, you will be getting hydroxide ions in the solution. Okay. Those hydroxide ions, they are appearing from water. See, water splitting up to give H plus and OH minus. You can add up these two reactions and you'll see that you have hydroxide ions in the solution. Right. So even if there is a strong acid dissolved in water, you get a hydroxide ion in the solution. And similarly happens the opposite way. If you have a strong base dissolved in water, so even that also has some H plus ions in the solution. Are you getting?
Yes, sir.
Yes. Yes, sir.
Yes. So even when a solution of acid is there, like this one HCl being dissolved in water, you are having H plus ions as well as the hydride ions. But whose concentration will be higher? The concentration of H plus or the concentration of hydroxide ions? Sumukh? Sumukh?
Hydroxide ions.
If the hydroxide ions concentration is higher, then it would be a base. Okay. And if the concentration of H plus ions is higher, then it would be an acid.
Acid.
Okay. So what do you call it? It's an acid or a base? HCl.
Acid.
Acid, sir.
It's an acid. You are getting H plus from HCl. You are getting H plus from water. All right. You are getting hydroxide ions from water only. So the concentration of the H plus ions will be higher, and therefore HCl will be an acid and not a base. Got it? So see, in the same way, you can write for NaOH also. Let's write down. Let's see what happens when sodium hydroxide is dissolved in water. Will it give us H plus ions?
No, sir.
No.
Yes, sir. Yes.
Oh my God. Then that means you haven't understood the concepts. See,
Sir, it
sodium
gives.
hydroxide.
It gives, sir. It
Yeah, you
gives.
will have NaOH combining with water. So obviously, you here you write Na plus ions will be obtained from this NaOH. You will obtain hydroxide ions from NaOH, and this H2O will also split up to give H plus and the hydroxide ions. Okay. So do you have H plus ions in the solution? Yes, we have H plus ions in the solutions which arises from water. Alright. So even a base will contain H plus ions, and even an acid will contain some hydroxide ions. Got it? So this we
Yes,
call
sir.
as
Yes, sir.
Na plus H. Alright. So now the term comes concentrated and dilute acids. So what are concentrated and dilute acids? Yeah. Can you, Lakshmi, can you tell what are concentrated acids? Lakshmi, Mandeep, what are concentrated acids?
Sir, sir,
Mm-hmm. Mm-hmm.
sir, having an acid having high percentage of acid in them,
Okay, a
like
solution of
less
acid.
dilution.
Okay, a solution of acid, okay, which has high percentage of acid content.
Yes,
Okay,
sir,
so a
like
solution of acid,
with less dilution.
yeah, so a solution of acid having high percentage or high amount of acid content. Okay, high percentage of acid content, we call it as the concentrated acid. And similarly, we have a dilute acid, an acid which has a low concentration, or an acid which has low percentage of acid in water. We call it as dilute acid. Similarly, we can have a concentrated base and we can have a dilute base. Got it? Now the next part is identification. Okay. So identification of acids. How do you identify acid? What tests? What are the tests for acids?
Sir, using phenolphthalein, methyl orange, and universal indicator.
All right.
Sir,
So,
turmeric,
hmm,
litmus.
uh, okay, for acids.
Sir, litmus also, sir.
Yeah, litmus. For acids, you have one of the tests as litmus tests. Any other test? Is the turmeric test for acids or for bases?
Sir, basis.
Bases. Turmeric test is
Sir,
for bases.
phenolphthalein.
Phenolphthalein. All right.
Sir,
Phenolphthalein.
phenolphthalein will also be for basis, na, sir.
Yeah,
Because
phenolphthalein is also for bases. Any other test for acids?
methyl orange, I think, sir.
Okay.
Sir, even pH strip paper will also help us.
pH paper. All right. You
Yes,
can
sir.
check the pH. So pH paper, litmus test, among all these. And you have some olfactory indicators. So what are those olfactory indicators?
Sir, the those
Well,
indicators which change the smell on action of acid or base.
Yeah, the indicators which change the smell on action with an acid or a base. They are called like olfactory indicators. So olfactory indicators can be used by a blind person to detect if given sample is an acid or base. Okay. So that vanilla essence or vanilla is one of the examples of an olfactory indicator. Okay. So tests for the acids, their litmus, pH, and others are there. Similarly, for bases also you have some tests. So for bases also you have a litmus test, pH test. Along with that you have the turmeric test also for the bases. The red cabbage test is there. Okay. Phenolphthalein, there are a number of tests by which we can identify whether a given substance is a base or not. How do we obtain litmus? How is litmus obtained?
Sir,
Sir,
originally,
from lichens.
From,
Lichens.
yeah, it is obtained from lichens. Litmus is obtained from lichens, which is a symbiotic association between an algae and a fungi.
sir, it is of the division Talophyta, sir.
Yeah. So from the division Thallophyta, they are lichens. So litmus is obtained as an extract from that. All right. So now I think you have done almost very good about acids and bases. Okay. So the next part is a reaction of acids. What are the reactions of acids? So let's say if you have an acid reacting with you have an acid, the acid reacts with a metal. We have studied very well about the reaction of an acid with a metal. So how do acids react with metals? How
sir,
do
it
acid?
forms salt and hydrogen gas is evolved.
Okay, salt and hydrogen. So salt and hydrogen, they are formed when so acid with metal gives us salt plus hydrogen gas. You have the evolution of hydrogen gas. So which all metals cannot evolve hydrogen gas? Yes, is there any metal which cannot evolve hydrogen gas on reaction with an acid?
Magnesium and manganese.
Which one?
So manganese and magnesium.
Why? Why they can't evolve hydrogen?
So because they are good oxidizing agents. So sorry.
No.
So sorry. I spoke it wrong.
Magnesium and manganese you are studying nitric acid. The nitric acid on reaction with the metal does not evolve hydrogen gas. The reason being that the nitric itself is a strong oxidizing agent. So it oxidizes the hydrogens to water.
Sir,
And therefore, there is no liberation. Hmm?
sir, metals like silver and gold, sir.
Okay, silver. First of all, look up at it with two things. Metals which are less reactive than hydrogen. Okay. In the reactivity series, the metals which are less reactive than hydrogen, they do not liberate hydrogen gas on reaction with the metal. They cannot cause those displacement reactions. They cannot displace the metal ion from their solution. Got it? So the metal ions cannot be displaced from there. So acid plus metal giving salt plus hydrogen. This is possible for all the metals which are which have the reactivity greater than hydrogen, and also it is possible with those acids which are weak, which are it's possible with almost all the acids except nitric acid. The nitric acid NO3 is a strong oxidizing agent, so it oxidizes the hydrogen which is formed to water. Got it? So acid plus metal will give you salt plus hydrogen. So what about a base? What happens when a base reacts with a metal? Yes. What
Sir,
happens when?
it is also the same. It also gives the same reaction.
Okay, it also gives the same reaction. A base reacts with a metal to form salt plus hydrogen. Can you give any two examples for or any one example?
Aluminium.
Aluminium.
Yes, sir. Like, no, yeah. Aluminum, sir.
Okay, aluminum reacting with which base?
Sodium hydroxide.
Sodium hydroxide. Okay. So aluminium reacting with sodium hydroxide. Very good. So all of you write down the reaction of aluminium with sodium hydroxide and zinc with sodium hydroxide. Write down both these reactions. Avinav, good evening. Did you join late?
Yes, sir. I have few internet issues. I joined at first, but then
Okay. All right. So can you tell when the base reacts with the metal? So I have write down the reactions. Everyone write down the reaction quickly.
we get Na2ALO plus H2, right? Sodium aluminate.
Na Na2 NaAlO2, which is sodium aluminate, and you obtain sodium zincate. These are the two salts which are obtained: sodium aluminate and sodium zincate. Okay. Also balance the reaction.
Sir, completed.
Okay, so sorry for the disconnection. I think I was disconnected during this time. Okay. So what is the formula for uh, sodium aluminate? Anyone who will tell the formula of sodium aluminate? Lakshmi, Lakshmi, are you there?
Yes, sir.
Okay, so what is the formula of sodium aluminate? You should remember this. Okay, some typical ones which you should remember. It is NaAlO2. Okay, so now we'll write this reaction and balance this. Sodium hydroxide combining with aluminium oxide. It gives us, so combining with aluminium, it gives us NaAlO2 plus hydrogen gas is liberated. All right. So, then in the same way, you can write down the reaction for sodium hydroxide combining with zinc. What compound you get? When sodium hydroxide combines with zinc, it gives the
Sodium zincate.
sodium zincate. Right? So you get the formula sodium zincate. Okay. Na2ZnO2, that is sodium zincate. All right. So students, any doubts up to here, whatever we have studied?
No, sir.
Okay, all right. Okay, so bye everyone. We'll see again in next class and continue with this
Sir,
chapter.
sir,
Yes, yes,
I have a doubt, sir. In
yes, please, please.
in human eye, actually.
Okay, please, you can ask any doubt any day.
Sir,
Hmm.
the sky appears blue because on when particles are only able to scatter low frequency, like high frequency ones, like blue light, right?
Yeah.
Then what about sunsets? Why does it appear red and orange?
Okay, so during this sunset, what happens? All the other colors are scattered, but it is the red color which is reaching our eye. The red color is not scattered, and it's the red color which is reaching our eye.
But the particles will be
Okay,
same, right?
okay, like this. See what happens. Uh, just 1 minute, I was explaining sunrise and sunset. So the sun during sunrise or sunset, the sunlight has to travel larger distances through the Earth's atmosphere. Okay, whereas during the afternoon, the sunlight has to travel shorter distances, smaller distances. Right. So the amount of scattering that occurs during the morning and the evening time is larger. For example, consider this atmosphere over here. So, okay, let this be the atmosphere. Now, let us see here horizon. So we have horizon over here. Now, this is the horizon, right? So now see, when the sun is located at this position, when you have the location of sun over here at this position, and when the sun is located at other position instead of here, suppose the sun is located over here. So when sun is located at this point, it has to travel larger distance. This distance from us to the atmosphere, it's a large distance. Whereas if the sun is over here, it has to travel a short distance. You see that the distance is decreasing.
Yes, sir.
Okay, so where will the maximum scattering occur? The maximum scattering will occur during the morning and evening, right? As the sunlight is traveling maximum distance during morning and evening, so there will be maximum scattering of light which occurs during morning and evening,
Okay.
right? And therefore it is only the red color which reaches our eyes, and hence we appear the sun to be red in color.
Okay, sir. Got it.
Okay, bye.
Thank you, sir. Bye, sir.
Mhm.